Welcome to your equivalent fractions review. So what are equivalent fractions? Two fractions are equivalent when they take up the same amount of space. So in this picture, we have two fractions. We have 1/3 and we have 2/6. And even though the sizes of the pieces are different, they take up the same amount of space in the whole, so they are equivalent to each other. So the question is, how do we find an equivalent fraction? Well, here we have a fraction, and that fraction is 1/2. And we know it's 1/2 because the shaded area is half of the whole area. One of the two pieces there are shaded in. Okay, so if I want to go about creating an equivalent fraction for 1/2, I need to cut all the pieces into the same number of pieces. That is, I have to cut both of them, in this case, into 2. So I'm going to go ahead and I'm going to cut them both in half. And by doing so, I created 4 total pieces, and 2 of those are now shaded in. The total amount of shaded area has not changed, but I changed the size of my pieces. And it's important here that I didn't cut one piece into 2 and then the other one into 3, because then I wouldn't have equal pieces anymore. I need to do them all into the same number of pieces. So what we did here is we doubled the total number of pieces and we doubled the number of shaded pieces. The size of the object actually stayed the same. So we took the 1 and we doubled that, and we also took the 2 pieces that we started with and we doubled those, so we end up with 4 total pieces. 2 of them are shaded and 4 is the total number. And then in this example, we are going to cut each of those pieces. We're starting out with 2/5, and you can see that on both of those models there. And then in the second picture, what we're going to do is we're going to split those each into thirds. So we have now effectively tripled the number of shaded pieces, and we now have 6 shaded pieces because 2 times 3 is 6. And we have tripled the number of total pieces, and we have 15 total pieces because 5 times 3 is 15. It's really important when we're trying to make an equivalent fraction that we remember to multiply both the numerator and the denominator by the same number. Otherwise, as you see in the first example up at the top, what you end up with if you just multiply the numerator by 3 here, what happened is we ended up with 3/3, which is actually 1 whole. The whole thing is shaded in. If we just multiply the denominator by 3, we end up with the fraction 1/9, and that's the second example. And that gives us this itty bitty piece that's actually smaller than what we started with. So you can see pretty obviously that that is not creating an equivalent fraction in either of those examples. And then, of course, the big question is, why does this work? Why can we multiply the numerator and the denominator by the same number? Well, it's because it's really the same as multiplying by 1. And we know that the identity property of multiplication tells us that anything times 1 is just itself. So we could effectively, use 7/7 as 1, or we could use 4/4 as 1, or we could use, 100 1/100ths, or 28 28ths. It doesn't matter which fraction we use as 1. All of these are names for 1, and therefore we'll end up with the same fraction when we are done. So here we have just one more example where you're multiplying the numerator and the denominator by the same number, and the resulting fraction in both cases is equivalent to our original fraction, because all of these equal 1. 7/7 equals 1, 4/4 equals 1. I could have done a millionths if I wanted to, but we are multiplying by something that is equal to 1. So what if your teacher has already told you what the new denominator will be? Then what do we do? So if we look at the first example, we have 1/8 equals something out of 24. And if I think about the multiplication that I know from my basic facts that 8 times 3 is going to give me 24. Okay, so I figured out what the multiplier is. In this case, it's 3. And then we have to make sure we're multiplying the numerator by the same number. And that's why you see in the bottom example there, we are multiplying by 3 and we end up with 3/24. At this point in time, what I want you to do is pause the video and try and solve these problems. The next slide that you see is going to give you the answers to all of these and show you how I did them. So stop here and give it a try. So you can use this slide here to compare what you had with what I had, and hopefully you were successful in being able to figure out what you were multiplying by in each of those cases. If you weren't, compare your work to my work, and you can also pause here if you need to. So actually what we can do here is we also can divide to find equivalent fractions. And that's because dividing by 1 is also giving us the same number. We know that 7 divided by 1 is 7 and 1,000,000 divided by 1 is 1,000,000. Whatever we divide by 1, we're going to end up with the same number. So we can also divide to find equivalent fractions if you notice that the numerator and the denominator have a common factor. So if you look at the first picture here, okay, we have 3/6. And if we divide the 3 by 3 and the 6 by 3, then we end up with the fraction 1/2. And 1/2 is equivalent to 3/6. You can see in the picture that they're the same amount of space shaded in. And basically what's happened is that those divisions that we had going horizontally, they just went away. And it's important here that we did end up with two pieces that were the same size. You couldn't end up with pieces that are not the same size because then you're not talking about equal pieces and you wouldn't be naming the fraction properly. All right, so why don't you try your turn at finding some equivalent fractions with division. You're going to pause the video here and give it a try. So here are the solutions for the problems that you just did. You're going to notice that in each case you're dividing by the same number for the numerator and the denominator. For example, in the first one, 8/12, we're dividing the 8 by 4 and the 12 by 4. That's the common factor there between those two numbers. And we end up with 2/3. If you were to draw those pictures, you would see that they are taking up the same amount of space within, the rectangles or the squares or the circles or whatever you drew. And you can take a look at the rest of these, compare them to your answers. If you need another review, you can go back and watch the video again from the beginning. Or I'm sure you could find something on another site such as Khan Academy or through the Study Island website. And if you have any questions, you can always ask me in class.